Today's session covers the features and value of the Power Loads and Thresholds page. To get to that page, navigate to Data Center Views, Power Loads and Thresholds. Let me make a few general comments about this page. Number one, all of the values on this page are given in a unit of measure watts. Second, this page is not giving an instant point in time metric. This page analyzes the power values over a period of time and gives you the results. In this case, this power has been updated over the past 30 days. So it's looked at all the minimum, average, and maximum values on every circuit, panel, PDU, UPS over the past 30 days and giving you metrics accordingly. Third, this view is looking at power from the bottom up. Namely, it starts at the rack. The first column sorts by rack. It then shows you what power circuits are in each rack, and each power circuit, it follows the power chain, the panel, the PDU, and the UPS, and ultimately the generator or utility for each power circuit. This grid list has the same filter and sort functionality as other grid lists on the portal. In other words, by clicking on the column headings, you can sort by that column, or by entering values in the filter boxes, you can filter the list. I will circle back later in the session and show you the value of such. But for initially, let's just start from the left to the right and let me talk you through these columns. As I mentioned, the first column is the rack. In this case, I'm looking at rack 2. In rack 2, I see there are two power circuits. Both of these power circuits are of the similar type, type 4. Clicking on the 4 opens up a description of the power circuit type. It's a 30 amp, 208 volt, 3-phase circuit with the following attributes. Next of interest is the panel that the circuit is fed from, this RPP panel, which is fed from PDU4, which is fed from UPS4. Continuing across the page, this circuit has a redundant allocation of watts of 2307 watts that will fail over to this circuit in a failure scenario. The primary allocation of watts on this circuit, based on the devices plugged in, is 2418 watts. Interesting, what I have measured, the most I have measured on this circuit is 2421 watts, which correlates very closely with the allocation. Jumping over to the blue columns, the policy for this watt, there's a policy for how many watts I can put on this circuit. But this column tells me how many available watts I have before I will hit that policy threshold. I have 4,177 watts before the policy threshold. I also have a circuit available watts before I hit the circuit threshold. 3,921 watts are available before hitting that. I have 39,910 watts available before the panel threshold, and so forth. On this circuit, I have 11 available receptacles that can be used for new devices. And I have this very important column, new device available watts. Considering all of the links in the power chain, this circuit has 3,921 available watts, and it's gated by the circuit. So what I'll see is if I look at all these blue available watts column, the most constraining is right here, the circuit, 3,921. That's what's displayed here. 3921. If I look up above, I see in rack 1, I have 8646 available watts, and it's constrained by the policy. So if I look over to the left, I see the smallest value here in policy. If I scroll down, I can see in various circuits I have different constraining elements giving me my new device available watts, and this page shows you whether it's the circuit or policy, which values are evident on this page. Scrolling further to the right, I see what my actual thresholds are. Again, in rack 2, following to the right, I see that my maximum watts per circuit is 8646. The policy statement I have on this rack is also 8646 maximum. The panel can handle 64,000 watts, the PDU 80,000, the UPS 120,000, and the generator 114,000. Finally, I can see that this circuit was last updated on August 16th, which happens to be today. Okay, so that's a high-level review, starting from the rack to the circuit and all the available watts metrics across. I would note here that the portal has specifically done the analysis for you and is showing us available watts. In a moment, I'll show you what the actual load is and how the available watts were determined. Before showing you how to dig further into power details, let me show you one other important clickable field, and that's the circuit name. Let's say that you're looking at the values, for example, the primary measured value on this circuit of 2421 watts, and you wonder, well, what kind of devices are plugged into this circuit that are deriving this value? You can see that by clicking on the circuit name. I'll click on this circuit name. It opens up a devices by power circuit report for the rack and the circuit I selected. Here's the circuit I selected, and it gives me a full list of all the devices by device name and by make model that are plugged into this circuit. It tells me how many power supplies are on the device, how many watts have been allocated to that device. It even gives me serial numbers. So using this click on the circuit, I can see what devices are drawing power. Now, let me show you how to dig down into power details. Coming over here to the circuit, for example, 3,921 watts. Wherever the cursor turns into a hand, I can click. So I'm going to click on that 3,929 watts and find out details. It lists the circuit. It gives me the trend showing me the average value of that circuit and the maximum value of that circuit over time. In this case, it shows me the past month of activity from July 16th to August 16th, average and maximum. The gearbox here allows me to modify the time. For example, maybe I want to go back for 3 months and look at this circuit. I'll start from May and go to August. Say OK, and the circuit trend will now show me the average and maximum values of that circuit from, in this case, April 30th to August 15th. I'll change it back to the past month. July 16th to August 16th. There you go. Also, I can see the measured value of the circuit and the redundant watts that could fail over to this circuit. in the dark purple is the measured value. In this case, it says 2420 watts. And in the light purple is the redundant value of watts that could fail over. Adding them both together, I get to a 4,727 watt allocated capacity on this circuit. The other valuable graph on this detail page is the phase balance. I can see here that phase 1, phase 2, and phase 3, and I can see that the delta between the phases is 11%, which is a fairly good balance. There's additional details here that I won't go into for the sake of time, but you ought to examine these. Just like I can do with the circuit, I can also click on the panel and I can see the detailed metrics on that panel. I can see the actual load and redundant load. I can see the panel schedule, what poles and what circuits are connected to each pole. Next, I can click on the PDU column and I can see the same details on the PDU. The actual measured load, the redundant load that could fail over to this PDU. And I can see the graph of the average and maximum values of this PDU. Like others, I can click on the gearbox, change the date range to see this graph over different dates, and the phase balancing. Likewise, I can click on the UPS, see the exact same metrics on the UPS. Let me now take a moment to show you the value of sorting and filtering by various columns. Let's say I want to know what the most constrained circuits I have in my data center. Here I have circuit available watts and the amount of watts available. If I sort by circuit available watts, ascending, it shows me the circuits that have the least number of available watts. In fact, here's a couple circuits that are oversubscribed by 197 watts. This should cause me some concern, and I probably have some remediation to do. But it goes on and shows me in order what racks and what circuits are most heavily used and constrained. Conversely, if I want to know what circuits are most lightly used, I'll click again and sort this column in a descending. So now I have the racks and the circuits that have the most available capacity for new commissions. Likewise, I can sort by panel to see the most constrained panel, or click again the least constrained. PDUs to see the most constrained PDUs. Click again the least constrained PDUs. If I want to see a summary of all the panel policy circuit available, I can go to the summarize new device available watts, click on that column, and I see a summary view. The most constrained circuits in this case, constrained by policy, and going down the list, I can see whether it's constrained by circuit, policy, panel, PDU, UPS. Or I can sort it in reverse order to see the most available racks and circuits I have in the data center. All right, this concludes the review of the power loads and thresholds page. I hope you found it helpful. Have a great rest of the day.